Hi everyone, welcome to the second tutorial to learn how to use CodeSnap 2600, a tool to create small games for Atari 2600 just using a visual way with blocks. Okay, in the last tutorial, so the first tutorial, we saw how to create a sprite, a player, that can be moved vertically and horizontally with the arrow keys and the joystick in a real 2600. So today we're looking at how to enable the second sprite and how collisions are working. Okay, so let's enable the second sprite. So let's create another bitmap. So I duplicate that. I call player 2 bitmap. And let's make something different. I don't know, like something like this. And so it's different from the other one. Okay, so now we have to create the variables to handle the x and y coordinates. So let's duplicate this. Let's call 2x into player 2y. This just defines the variables. Now we want also to set the variable to a specific coordinate on the screen. So let's duplicate also the set. Okay, the 2x, let's say that we do, I don't know, 70. And the 2y we initially set at a little bit higher, so like 30. Okay, so we also need to set the color. Otherwise it will be black and we'll not see it. So we do player 2 and we can use white as well. F0, F is white. Okay, now we want set the image, the sprite, to be used. So we can duplicate that one. So this is the one that set the player bitmap to a specific one. So let's say player 2, and we set to player 2 bitmap. And then we have to set also the horizontal coordinate for player 2, like this one. So we duplicate the same we did in the first tutorial for player 1. We do player 2, coordinate is in player 2x. We don't have to apply this 2 times. As said previously, we do any horizontal position setting, then we just apply 1 time this horizontal move. And let's try and see what happens. Yet still nothing, because I forgot to enable the player here. So we enable, we verify that the variable is 2y, so that is the one we were using here, so for the y coordinate. So let's try again, and now I have another player. This is the same image that we created here. Okay, now as before, the player 1 can still move, but nothing happens when it touches the player 2. So let's look at the collisions. Okay, so collisions has 2 phases. The first one is, can I say here, we decide what we want to check for collision. We can check collision between any object to any other object, to playfield, to player, missile. In this case we have player 1 and player 2, so we can select when collision happens between player 1 and player 2. So what can we do? We can say the color of player 1 changes when there is a collision. Okay, so let's duplicate player 1 color. Let's put here, so we want that is white, so 0F, when there is no collision, else. But when there is collision, we want another color. Let's say 34. It's like a reddish color. And also another thing, we need to clear a collision. So we can have, similar to this apply horizontal move, we can set multiple collisions, but at the end we have to clear the situation, so for the next loop the collision could be detected correctly again. So let's generate assembly, compile. Okay, it seems the same as before, but if I go above the other player, as you see, the collision is detected and this happens. So the color changes. When the collision is no more detected, like here, the second one happens. So because we are looking at this, I can show you a thing that happened to me while testing this. So we can move this collision in the overscan. So as I said before, this part, the V-blank and the overscan, are both sections used for the logic, for calculation, for preparation for the video. And this is the section that actually shows on the screen. So if I move this here in the overscan, both, so if I do generate a assembly, compile, still works. But one problem that could happen is, as you see here, I have set player 1 to F in the initialization. But let's say that for error, instead of initialization, this is in the V-blank. So one thing to remember is if I click on one block, we'll move all the blocks below. In this case, I didn't want that. So I press Ctrl, and then I can move just this block, and I put here. So now, if we try again, it seems that the collision doesn't happen, but really happens. So let's look at what happens in this game. So the variables are set at the beginning, then these are initialized, so the coordinates are initialized, and also the color of the player 2 is initialized at the beginning. Then, as said, this is a loop, so the game, after this initialization, starts looping between this logic part, visualization, other logic, and then goes back to this. So in this case, what happens is that this part is set, so the color is set to white of player 1, the player is visualized, then the collision is detected, and the player color is set to red. But because the loop goes back to here, then the player color is set back to white, and then when we will be visualized, will be still white. So the correct way to handle that is or to move this section here, then even if I set to white here, the collision is detected and set the color before visualization. Let's try. As you see, it works. Or if you want to keep this in the other logical part, just to divide the work over two logic section, I have to move this, still press Ctrl, to the initialization. So I want the player to be initialized to white only one time. And of course, as we tested before, this should work correctly. Really, what we can do is we can even delete that one, because every loop, this collision check, if a player is, so if there is a collision, player is set to red, otherwise it's set to white. So it's always set to some color. So we can save a command that is not useful. Okay, I think it's okay for this tutorial. Thanks for watching, and see you in the next one.